Bismillahirrahmanirrahim. Amplitude modulation is a method of transmitting information, such as voice or music, by varying the amplitude of high frequency carrier signal, which is proportional to the instantaneous value of the information signal, also known as modulating signal. While the frequency and phase of the carrier remain constant, and the amplitude changes according to the content of the message signal. This technique allows the information to be superimposed on the carrier wave and transmitted over long distance, while it can be recovered at the receiver by detecting the variation in the carrier amplitude. Amplitude modulation is widely used in radio broadcasting and making it one of the simplest and most common form of modulation. In the previous unit 9 and 10, we explored and comprehensively discussed the concept of modulation, what is modulation and why modulation is so important in modern communication system. And then we discuss different types of modulation. Now we are going to start our first type of analog modulation method, which is amplitude modulation. And it is a part of our chapter number 2, amplitude modulation techniques. Amplitude modulation is a simple but very powerful concept in communication system. Amplitude modulation or AM is the technique used to transmit information like sound or data over long distance. It works by taking a high frequency carrier wave as shown in the figure and varying its amplitude in proportion to the message or modulating signal. The carrier wave represent mathematically as a VCT is equal to VC sine omega t, where VC is the amplitude and omega c is the angular frequency of the carrier wave. And similarly, the modulating signal VMT is equal to the Vm sine omega mt, where Vm is the amplitude of the modulating signal and omega m is the angular frequency of the modulated signal, such as voice or music. So when two signals are combined through the process of modulation, the carrier amplitude start to vary based on the instantaneous value of the modulating signal. And one key point to note that the frequency and the phase of carrier signal remains unchanged during modulation. Only its amplitude is modified. This makes amplitude unique and straightforward as all the information is encoded within the amplitude change of the carrier wave. The result is an amplitude modulated signal whose envelopes mirror the shape of the original uh, signal as shown here. In a compelling illustration, you can see that the carrier wave and message wave combine to produce the modulated signal. The envelope of this wave represents the message signal, and by detecting it, we can recover the original amplitude, original information. Amplitude modulation has been a cornerstone of modern communication, especially in amplitude module radio broadcasting, where it enables the delivery of audio content across great distance. Its simplicity and effectiveness have made it a fundamental concept in electronics and communication. According to the fundamental definition of amplitude modulation, we can define Vam is equal to Vc plus Vm sine omega mt, where Vc is the amplitude of this carrier wave and Vm is the amplitude information of the message information modulating signals, and Vam is the amplitude of modulated signal. So when we take VC carrier amplitude as a common, so our equation become 1 plus Vm over Vc sine omega mt. And now we introduce another terminology which is called MA modulation index or depth of modulation. It has a different name in literature. So we can replace Vm over Vc by MA, and our equation is Vm is equal to Vc 1 plus Ma sine omega mt. We will discuss in little detail in next slide, but first here we just introduce that modulation index or coefficient or depth of modulation is the indicator to describe the amount of amplitude change present in the AM wave, and basically stated in the form of percentage. We can write that MA is equal to VM over VC multiplied by 100. Generally, track represent 60%, yeah, 70%, yeah, 100%. This varies from 0 to 100%.